All right, so in this lesson, or this half of the lesson, we're going to be focusing in on area. So example 4 asks you to find the area of a rectangle. Now, if you read through this, it says similar to the one at the right. I didn't include the image, okay? But it says the dimensions are 212 feet by 5 feet, and it asks for your units to the nearest square yard, okay? So what I'm going to do is I'm going to find the area, length times width, in square feet first, and that's 1,060 square feet. To convert this to yards, it's worth knowing that there are 3 feet in a yard, but if you're converting square feet to square yards, instead of dividing by 3, you're going to divide by 3 squared, okay? So to convert units, you divide by the units squared. So 3 feet squared, 3 square feet, sorry. Converting that from feet to yards, you divide by 9. So 1060 divided by 9, it's going to be about 117.8 square yards if we're rounding to the nearest tenth. So it's about converting units either before or after you do your calculations. So for number 4, I'll just go through that with you really quick here. You're designing a poster. That'll be 3 yards by 8 feet. So 3 yards by 8 feet, the units do not match up, but I want the answer in square feet. So with this example, I think it would be worth it to convert the 3 yards to 9 feet, because then the calculation is a little bit easier. You have 9 feet times 8 feet, which is 72 square feet. So sometimes it pays to convert the units at the end. Sometimes it pays to convert the units earlier. It all depends on the situation. For example 5, finding the area of a circle in terms of pi. Well, it's worth noting that the area of a circle is pi times the radius squared. So we have to know the radius of the circle. So what we're given actually is the diameter of the circle, which is 16, which means the radius is 8 meters. So for area of a circle, it's pi times 8 squared, which is 64 times pi. That would just be my answer in terms of pi, 64 pi. If I was asking for it to the nearest tenth, you would multiply 64 by pi in your calculator and round to the nearest tenth. So what I want you to do next, real quick, I want you to go through A and B. You can skip C for now. And then it says you find the area in terms of pi, and then what's the area using pi as an approximation. So just use 3.14 as an approximation, okay? And I'll explain why in a second. But I just want you to pause the video, try both of these, and then you can resume the video and I'll kind of explain just a little bit on how I went through both of these examples. Okay, so for the first part, it's recognizing the diameter is 14, so the radius is 7. I square the radius, I multiply it by pi. In terms of pi means you just treat pi like a variable. You don't convert pi to a decimal. You don't round. It's just an exact answer, 49 pi. For part B, this is if you use 3.14 for pi, which is what I don't generally want you to do. But sometimes, if you're doing a quick calculation and the accuracy isn't as important, you use an approximation. I want your calculations, I want your formulas to be precise. So we're always going to use pi when we calculate something. Never approximate pi to 3.1 or 3 or 3.14. You have access to calculators, use your calculator to find that value as precisely as possible. So the next part we're going to talk about is called the area addition postulate, which just means the area of a region is the sum of its areas of non-overlapping parts. So in example 6, you're finding the area of an irregular shape. So you've got to split this shape up into more familiar shapes. So what I would do with this shape is I would split it up into more familiar shapes. So One thing to notice is that you have some squares, right? You could split the shape up into a bunch of squares. So I'm noticing there's a square here, and there's a square right here, and there's really a square right here, and there's a rectangle on the bottom. So each of these squares I split up are 3 by 3, 3 centimeters by 3 centimeters. So each of those squares, has an area of 9 square centimeters. Okay, 9 square centimeters. And at the bottom, this rectangle is a 9 by 3 rectangle, which means it has an area of 27. So the area is really me just adding 9 plus 9 plus 9 plus 27, which gives me an area of 54 square centimeters. So it's about splitting the shape up into more familiar shapes, finding the areas of those shapes, and adding them together. So in the next part, if you can split the shape up in a different way, you can do that. But what I really want you to focus on is part B, find the area of this figure to the right. So I'm going to give you a few seconds to do that. Good chance to pause the video, work through it, and then when you're ready, check your answer, and we'll move on to the last example. Okay, so for part 7, you want to adopt a puppy from your local animal shelter, you want to build an outdoor playpen, and cover it with AstroTurf. So we've got to find the area of this pen, and if we want to lay down the turf, we've got to buy it. It costs $1.70 per square foot. So it's about understanding that this is split up into 2 triangles and a rectangle. So the rectangle in the middle of this pen is going to be a 6 by 3 rectangle, 6 feet long, 3 feet wide. So that's 18 square feet. Each triangle, I'm going to do triangle 1, triangle 2. They are the same size and shape, so they'd have the same area. But these triangles have a base of 1 and a height of 3. So that means they're 1/2 times 3 times 1 square feet. So they're each 1.5 feet squared. So I'm taking 18 plus 1.5 plus 1.5. So the area, the total area is 21 square feet. Okay, 21 square feet. The cost, all I have to do is take the 21 square feet times $1.70 per square foot. 21 times 1.7. It would cost me $35.70 to put turf down in that yard. So it's about splitting the shape up into more familiar shapes and then adding up the areas once you find the areas of those more familiar shapes. So you're ready for the practice, probably ready for the checkpoint by now.